Welcome to the XFO Intelligence Podcast. Today, we are pulling back the curtain on the state of artificial intelligence in 2026. And I want you to forget the breathless headlines, forget the daily hype. Using our Deep Augmented Thinking method, we've synthesized a more fundamental picture of where we truly stand. And what we've found is, well, it's a landscape defined not by radical change, but by surprising stability, fierce strategic competition, and these just inescapable economic laws. The story of AI today is not the one you're being told. Let's begin with the core technology, because if you only followed the news, right, you'd assume a revolutionary new model architecture is born every single week. The reality, though, is far more stable. The state-of-the-art models of 2026 are still fundamentally based on the transformer architecture from years ago. Its lineage, you can trace it directly back to GPT-2. Of course, there have been clever incremental tweaks, things like mixture of experts, to pack in more knowledge without the compute cost, variations in attention mechanisms, refined normalization. But as Sebastian Roschke notes, you can still start with the blueprint for GPT-2 and by adding these components, build a state-of-the-art 2026 model. It's all the same family. So if the architectural revolution has stalled, where are the real breakthroughs? They're in how we train the models. The innovation, it's really a three-stage paradigm. First, you have pre-training, where the focus has shifted dramatically from just the sheer quantity of data to its pristine quality. Second, there's a specialized mid-training phase, which is designed to instill specific skills, like long-context reasoning. But the third stage, post-training, that's where the game really changed. The breakthrough of 2025 was a technique called reinforcement learning with verifiable rewards, or RLVR. Now, unlike its predecessor, RLHF, which really hit a wall of diminishing returns, RLVR, it scales with this beautiful predictability. A logarithmic increase in compute yields a linear gain in performance. The mechanism it's really elegant. You give the model a problem with a provably correct answer, like a math problem or a coding challenge. The model is rewarded for accuracy, and it just iteratively improves. And that process, that's what unlocked the robust reasoning and tool use capabilities that define today's leading models. It's what enables an AI to seamlessly handle commands in your code repository, or, and this is amazing, in its now famous aha moments, self-correct its own logic during extended thought. This technical reality directly shapes the second major force, global competition. January 2025, that marked a real watershed. A Chinese company, DeepSeek, released a model that achieved near top-tier performance, and allegedly with just a fraction of the compute. This DeepSeek moment catalyzed an explosion of powerful, open-weight models from Chinese firms like Qwen, Kimi, and Minimax. And crucially, their licenses are truly unrestricted, a stark contrast to many Western open models. So why? In leaning, this isn't about philanthropic ideology. No, it's about sharp, calculated strategy. These companies know that U.S. firms are unlikely to subscribe to their APIs, due to security and geopolitical concerns. So how do you capture the global market and build influence? You release your powerful models for free. You let the world build on your technology, embedding you in the global ecosystem. It's a brilliant strategic pivot, and yeah, it's working. Meanwhile, over in the U.S., giants like Anthropic, Google, and OpenAI are cementing their dominance through these closed, integrated platforms. So you have Anthropic's Claude 4.5 leading in coding, Google's Gemini 3 in long context, and OpenAI's GPT-5 in balancing intelligence and speed. The U.S. advantage, it lies not just in the model itself, but in the polished user experience, the deep tool integration, the entire platform. And this brings us to the third and maybe the most clarifying insight, the unyielding economic and systemic laws governing this entire space. If you remember one thing, let it be this: serving costs now dwarf training costs. A company might spend, say, $5 million to train a world-class model, but serving that model to millions of users, that could be billions. This single economic fact has completely reoriented the field. The race is no longer just for raw power, it's a race for inference efficiency. It's why we're seeing models get smarter, but also smaller, kind of settling around 1 trillion parameters. The bottleneck is no longer creating intelligence, it's delivering it affordably. This economic gravity, it's one of several powerful system dynamics at play. We're seeing a success to the successful archetype, where the top labs attract the best talent and compute, creating this winner-take-all vortex. And we also face a tragedy of the commons, as the internet becomes saturated with AI-generated content, poisoning the very data pool needed to train the next generation of models. So what does all this mean for us, for society? This is where the analysis becomes deeply human. A defining trend is the model's ability to use tools. They can call a calculator, search the web, run code, and this is a critical step in engineering trust because it reduces hallucinations. Instead of guessing, the model just outsources tasks to reliable, verifiable sources. Yet this creates a paradox. For us, for human beings, productive struggle is essential for deep learning. We're now seeing that senior developers use more AI-generated code than junior developers because they have the foundational expertise to leverage it effectively. This poses a profound question for education. How do we use these tools to assist learning without eliminating the very struggle that builds mastery? And perhaps the most crucial insight is about agency. The popular fear is of an AI that seizes control. The 2026 reality is that the human remains firmly in charge. As Rashka says, the AI is not in charge, you're in charge. These are not autonomous agents, they are powerful tools that amplify human intent. Looking ahead, we should expect continued amplification, not another sudden paradigm shift. We will see a rise in specialized models that are fine-tuned to outperform generalist ones on specific tasks. And we will witness the rise of a premium on authenticity. As the digital world fills with AI-generated content, real, in-person experiences and verifiably human-created work will become more valuable than ever before. The AI revolution of 2026 is less about a machine that thinks and more about humanity learning how to think with these new machines. Now, here's a question we'd like you to think about. As these incredibly powerful tools for amplification become woven into the fabric of our work and lives, how do we consciously design our workflows, our businesses, and our educational systems to protect and prioritize the essential human qualities of agency, deep learning, and authentic creation?